All right, guys, to start out with today, what I'd like you to do is I would like you to look at these two sets of matrices. The first one, notice you have a 3 by 3 matrix that's being multiplied by a 3 by 1 matrix. So I want you to see if you can figure out what the resulting matrix would be for that one. Now that one you're not going to be able to type into your calculator. You'll have to think back to our rules that we had for multiplying matrices. And as a hint, your matrix will still have the variables of x, y, and z incorporated in it. For the second one, you are going to enter that into your calculator. Notice that first one looks a little bit messy, but we'll talk about what that is and why or what the result is and why that's going to be a special result. So go ahead and you can pause the video and figure out what the solution for both of those multiplication problems would be. All right, well, let's look at this first matrix and see what we should have had for this one. First of all, this again was a 3 by 3 matrix. And this one was a 3 by 1 matrix. So we know that our resulting matrix should also be a 3 by 1. So if I take this first row times the first column and do addition as I go, I'm going to have 4x plus y plus 2z. And then I move on to the next row, and I'm going to have 5x minus y plus 4z. And finally, the last one, I'm going to have 7x plus 6y minus 3z. And that would be our resulting matrix for that one. Now, again, that's one we couldn't type into the calculator since we had those different variables involved. Now, when you got this second one, or when you attack this second one, this time we're looking at two 3 by 3s. So when we had two 3 by 3s, we know our resulting matrix is also going to be a 3 by 3. And hopefully what you found once you type that into the calculator is you got this for a result. So we kind of got a strange looking matrix there, but notice that matrix had ones along the diagonal and every other value was a 0. Well, that matrix actually has a special name. That's what's referred to, I can get this to work here, as the identity matrix. Oops. And a lot of times that identity matrix, we're going to use a capital I for. So if I go back to the original two matrices here, maybe I label this one with A. And if I multiply A by a certain matrix and I end up with the identity matrix, that means this original one was what's referred to as the inverse matrix, or capital A with our inverse notation. So in other words, if I ever multiply the inverse times the original, I should get the identity. Now, what's special about the identity? Well, the identity matrix if I ever multiply a matrix by that identity matrix, I get back to where I started. For instance, and we won't go through all the steps, but if I were to take this row times this column, well, I would have 2 times 1, or 2, and then 1 times 0, negative 3 times 0, so my first entry would be a 2. If I took that first row times the second column, well, now I have 0, and then I'm going to have 1 times 1, and then I'm going to have negative 3 times 1, and I get 1. If I took it times the last column, it's going to be 2 times 0, or 0, 1 times 0, or 0, negative 3 times 1, which is negative 3. And what I end up, if I went through all the steps, is I'd end up with the exact same matrix that I started with. So this one would have now become here had I multiplied those two together. So a couple special matrices. The inverse matrix times the original gives me the identity. And the identity matrix is just a matrix that if I were to multiply by the identity, I would get the original matrix back. All right, so how's this fit into what our next step is going to be? Well, for today, you're supposed to have a systems of equations worksheet set up or completed. And we've been working with these matrices, we've been working with the systems, but these two actually are going to go hand in hand. So let's see how we could use matrices to help us set up a system or help us solve a system of equations. So here's one of the problems from your worksheet. And we're going to try to use matrices to help us solve this. Well, basically, the first thing I'm going to look at is I'm going to look at what are all the coefficients for this system. Well, the coefficients for the first equation were 2, 3, and negative 1. So I'm going to set up a matrix here. That has 2, 3, negative 1. Because those were the coefficients here for that first equation. Now I'm going to do the same thing for the second equation. So the coefficients were 3, negative 2, and 2. Then the last equation is 1, 1, negative 3. I'm going to call this matrix A, but a lot of times I'll refer to this as the coefficient matrix. Well, technically what's happening in this problem is I've taken all those coefficients and I multiplied by the variables that I was missing, x, y, and z, kind of like we did for the warm-up problem. I'm going to call this matrix X, or the missing matrix. Well, if I went through my steps, I'd have 2 times x, 3 times y, negative 1 times z, and that would be my first entry. But I know what my first entry is equal to already. I know once I multiply those, I would get 9. Same deal for the second equation. I know I'm supposed to end up with 8. And for the last equation, I'm supposed to get negative 7. I'm going to label this with B, or a lot of times I'll call that my answer matrix. So I have my coefficient matrix times the unknown, and that's equal to the answer matrix. Well, if I just gave you this equation, AX equals B, and I asked you to solve for X, which is really what we want to know, what's the unknown matrix? Well, in a regular old equation, we just do some division. Here's the problem though. With matrices, unfortunately, we don't have a division operation. So somehow we have to undo that matrix of A in order to get X by itself. Well, that's where the idea of the inverse comes in. So what I really need to do is I need to make this get to a point where if I multiplied this by XYZ, I would just get XYZ. Well, if I were to multiply A by its inverse, we just said that would give me the identity matrix. Well, if I take the identity matrix times X, I would get back X. But just like any other equation, if I did that to one side, I got to make sure I do it to the other side. Now notice I put the identity matrix first, or I'm sorry, the inverse matrix first. And that's because it was first over here. So in other words, if I want to figure out my missing values, I want to do A inverse times B. So here's what I'd like you to do. First of all, in your graphing calculator, go ahead and enter in matrix A, and then enter in matrix B. Now, unfortunately, here at home, I don't have the display for the calculator, so you're going to have to just enter those in on your own. So we have 2, 3, -1, 3, -2, 2, 1, 1, -3. And then you want to put the answer matrix as matrix B. And notice that's a 3 by 1. Okay, so to remember to pull up those matrices, you're going to go back to the home screen, so second mode. You're going to go to the matrix option. You're going to select A. Now here's where it's a little different because we want A inverse. Well, the button we've been using for the matrix, we've always hit second and then that X to the -1 button. Well, that X to the -1 button is really the inverse button. So if you pulled up A, you just hit that X to the -1 button, and it should now display something like this. It should say on your calculator, and again, sorry I can't show you this, but it should say this now. And we're going to multiply that now by matrix B. So we select B. And your calculator should display this. 2, 3, 4. Which means that X was equal to 2, Y was equal to 3, Z was equal to 4. And a lot of times we're going to display this as an ordered triple. So we'll go in alphabetical order. We've done ordered pairs before with X's and Y's. With X, Y's, and Z's, we have an ordered triple. So 2, 3, 4. So that's how we can set up matrices in order to solve a system of equations. So let's try another one. All right, this is again another one off of your worksheet. So what I want you guys to show me, I want you to show me first of all the matrices that you would set up. So for this one, the coefficients were 1, -3, 2, 2, 1, -2, and 1, -2, 1. We're going to multiply that by x, y, z again. And that's going to be equal to our answer matrix of 3, -10, 0. All right, so again, this is A, this is X, this is B. All right, in order to find X, we're going to do A inverse times B. So why don't you go ahead and type those into the calculator and see what X, Y, and Z should have been for this one. So once you type all that in, then you do your multiplication, you should have gotten this matrix, which means this is our solution. So to kind of practice that, I'd like you to check your other answers from that worksheet that you're supposed to turn in for today. And from here on out, unless it says solve algebraically, which we will have you do sometimes, we'll have you do it by hand. But unless it says to solve them algebraically, I'm okay with you using matrices to solve the systems. But you have to set up the matrices like I have here and show me what your matrices would be when you actually enter those in. Okay, so don't skip that step. Don't just write down answers. It's okay to use the calculator and the matrices, but again, I want to see those things. So once you pause the video, take a couple minutes, check your other answers by setting them up on the matrices. And then there's a second part to what I want you to kind of learn today. All right. Well, the second part of today's is talking about how could I figure out what the equation of a quadratic would be if I know certain points. Now we've done like the equation of a line given 2 points. You've done the equation of an exponential given 2 points. We've even done the equation of a quadratic given 2 points. However, when we did the equation of the quadratic, we had to have a special point. If you remember, we had to know the vertex to only get away with 2 points. Well, this time they gave me 3 points, but they didn't tell me if one of them was the vertex. And in fact, we don't know any of these is the location of the vertex. So how are we going to find the equation of the parabola if I'm only given this information? Well, if you remember, there's a lot of different ways we can write our parabolas. We had vertex form, we had factored form, but we also had standard form. Remember, our standard form was y equals ax squared plus bx plus c. Well, when we did exponentials, one of the methods that we used was we just plugged in the information we had, and then we did a system of equations to solve for, with the exponentials, a and b. Well, here I really need to know what a, b, and c have for values in order to know my equation. So here's a way that we could attack this. I'm going to start with the first point they gave me of 1, 0. And I'm going to plug 0 in for y. And I'm going to plug 1 in for x. Then I'm going to go to the second point and do the same thing. I'm going to plug 5 in for y. And I'm going to plug 2 in for x. And finally, the third point, I'm going to plug 12 in for y. And I'm going to plug 3 in for x. So basically, here's the system that I'm going to try to solve. 1 squared is 1, so I'm going to have a plus 1 times a plus c is equal to 0. 2 squared is 4, so 4a plus 2b plus c is equal to 5. And 3 squared, or 9a plus 3b plus c is equal to 12. So I'm trying to solve this system of equations. Well, I could do this by hand, and this one actually wouldn't be too bad to do by hand because notice I could eliminate the c's fairly quickly. Or now I can use my matrices to help me. So my coefficient matrix would have 1, 1, 1, 4, 2, 1, and 9, 3, 1. Multiplying that by ABC to end up with 0, 5, 12. So ABC should be whatever A inverse times B is. So let's enter that in and see what we get for that matrix. So when I multiply A inverse times B, I get the matrix 1, 2, negative 3. But remember, what they wanted me to do is write the equation of that parabola. Well, in standard form, I now know that A is 1, so I have 1x squared. I know B is 2, so plus 2x. And I know C is negative 3, so minus 3. So the equation of the parabola that went through those 2 points, 3 points I should say, was y equals x squared plus 2x minus 3. All right, so why don't you guys try this one? Again, trying to find the equation. We can find it in standard form using these 3 points. So you can pause the video and try this one. All right, so when you tried this one, hopefully you plugged in 10 for y. 3 squared would be 9, so 9a plus 3b plus c. Then 36 is equal to 25a because 5 squared plus 5b plus c. And lastly, 15 equals 4a minus 2b plus c. So again, show me the matrices that you're going to use. So in this one, 9, 3, 1, 25, 5, 1, 4, negative 2, 1, times ABC equals, or 10, 36, 15. And so x would equal, again, the inverse of A times B. And I haven't typed that in yet, so let's see. Get 2, negative 3, 1. So my equation, y equals 2x squared minus 3x plus 1. All right, so a couple things there that we need to be aware of, knowing how to start with a system of equations, set up the matrices, and then use those matrices to help us solve. And then we can apply that to a situation where we are given 3 points and we want to find the equation of a parabola that goes through those 3 points.